Oh, yes. Good afternoon, and welcome to the afternoon session at AIAA SciTech. I'm Graham Warwick. I am the executive editor for technology at Aviation Week, and kindly, I think, AI asks me back to SciTech every year to moderate a panel, the panels of which get more and more challenging every time I do one of these ones. So anyway, the theme of this SciTech is about expanding boundaries. Now, aerospace is all about expanding boundaries, human boundaries, but specifically what AIAA is trying to get here is expanding beyond the boundaries that we have created for aerospace in doing what we do, expanding beyond the silos, beyond the disciplines that we have created in order to achieve what we have achieved. They're talking about expanding boundaries by embracing interdisciplinary approaches and encouraging collaboration amongst diverse skills and organizations, which if you are in the industry or entering the industry, you'll realize is not as easy as it looks. We have the boundaries we have because they've worked in the past, but they don't necessarily work in the future. So we need to find ways to expand beyond those boundaries. So this morning's Forum 360 panel explored how non-traditional technologies could impact future capabilities and operations. Apparently, particularly AI was of great interest this morning. This afternoon's panel takes the perspectives of my colleagues here on the stage who are anticipating next generation missions and identifying, nurturing, and advancing technologies that could be game-changing, will be game-changing, even into generations after next. So we're talking about potentially looking a long way into the future. They are the custodians of the crystal balls that are becoming increasingly faceted, not clear, but faceted, and complex, and more like a constantly changing kaleidoscope that you have to look deep into and look for the patterns, for the connections that will enable those breakthrough capabilities. So I'll introduce everybody, and they'll all have say a few remarks to get us started. I've just realized, or just been told, we're all arranged in alphabetical order by last name. I didn't realize that till I walked up to this thing. So our first speaker is Professor Dr. Thomas Dekorsy. He's director of the Institute of Technical Physics at German Aerospace Center, DLR. His main scientific interest is in the development of new laser systems for aerospace, defense, and security. Thomas, give us an overview.
Yeah, thank you very much for having me.
Welcome, and give us an overview.
Thank you for having me on the panel as somebody from DLR, which is a big German aerospace center and also corporate member of AIAA. So let me start off with a citation, which some of you may know. May you have a strong foundation when the winds of changes shift. That's from a Nobel laureate in literature, Bob Dylan, and it's about, the text is about lifelong learning and teamwork, and I think that's what we need when we want to reach breakthroughs also in technology. Some words about my personal background, which is in physics, so that's my personal strong foundation, so to say, with specialty in quantum phenomena, in solid state, semiconductor physics, and laser physics, and I've been a professor in the physics department for 15 years in Germany, and 8 years ago I joined German Aerospace Center. Now I'm director of an institute working on laser systems for aerospace. And I also like to mention that over 60 participants at this conference come from German Aerospace Center. So the institute I'm directing is working on laser applications in the fields like new sensors for airplanes, like measuring true airspeed, angle of attack, and so on. Also we are working in space. We're working on laser ranging of satellites, which is also very important if you think about the congestion in space, especially in low Earth orbit. And last but not least, we work on directed energy applications, lasers for defense. For me, and luckily, lasers are often at the heart of breakthrough technologies, especially in aerospace. If you think about additive manufacturing, quantum cryptography, or about laser-based communication between satellites. And what we are working on in our institute is, for example, looking at things like changing the trajectory of satellites or space debris with high power lasers through photon pressure. Also, as I said, laser communication, additive manufacturing, for example, for 3D printing on the moon, something which we can envisage. Some words I like to say, what are the necessary skills which I think we need in the future for having teams to work on breakthrough topics. And I think, coming back to the citation I had, that a strong disciplinary education is important. It's important to know one subject by heart and the tools and the methods, be it aerodynamics, orbit mechanics, you name it, and you know what you are burning for. And I think then in the education, the interdisciplinary skills have to be acquired by working on teams, on projects in an interdisciplinary way. And then also, like we heard in the morning by this great plenary talk and already in the other plenary discussion, we now see the big change through AI. And that's the question how AI will support further the breakthroughs in one or the other way, maybe also in ways we cannot foresee today. And also I see a danger when I think about the development in AI and the workforce, that is a motivation of young people to go into tech areas and choose their career there. It may be discouraging to compete with your human creativity against the creativity or what AI is producing. But I think the breakthrough technologies will be very, very complex, and I think AI may help to accomplish them, but we definitely need bright humans to do that.
It's a really interesting point about being discouraged by competing with AI. I mean, I'm a journalist, and you're seeing AI being applied to writing, and you have to find a way to raise your game. I mean, to distinguish, set yourself apart. I want to just ask, it was really interesting because you kind of think that lasers are old hat, I mean, they've been around for a long time. When you look at, you listed some applications there, how much of what you do is driven by a foundational advance in laser technology versus a new way of using a laser, right? So satellite navigation, space navigation, debris removal, 3D printing on the moon are all new applications. Is the technology the same and it's just reapplying but to a different? So how much would you look at your roadmap, how much of it is fundamentally new laser, advances in fundamental laser technology? How much of it is just somebody saying, hey, we can do that?
That's an excellent question. What we do in our institute is we have the full chain of developing new lasers to the systems which we want to build. And if a laser system does not exist, we try, if it's not available somewhere for some other purposes, we really try to develop that. We work on new concept for direct use of semiconductor lasers for high power systems without going to transfer first the energy to a solid state laser, and then again, it's a more efficient system. Yes, we need also new breakthroughs in laser technology, because these lasers, for example, which we would need for nudging the satellites, do not really exist in the way we would need them. I mean, this is a complex system. You also need adaptive optics. You need large telescope. You need exact tracking if you want to do this ground-based, others are trying to do it satellite-based, which comes with some other difficulties to have high-power lasers in space. Not all the lasers exist which we need for what we anticipate could be, in principle, physically done with lasers in the field of aerospace.
Interesting. So our next panelist, excuse me while I get myself organized here. The next panelist, Dr. David Lambert, is Chief Scientist of the Munitions Directorate at the US Air Force Research Laboratory in England, in Florida. With a technical background in detonation physics and penetration mechanics, it says in the bio. That sounds pretty explosive to me, but he is the principal scientific and technical advisor to the Directorate, which leads the US Air Force's development of technology for conventional weaponry. So David, give us your perspective.
Hey, thank you for the introduction and opportunity to be on the panel. This is my first SciTech. So I think in AIAA, I've associated with some of the forums before, but as far as the SciTech forum, so appreciate the opportunity and a wonderful crowd. I got 3 areas I'd really like to cover. One is accelerating that technology maturation and transition into systems. That's ultimately what all of us would like to do. The other one is the data and digital transformation realm, which I think is an enabler for a lot of that. And then really that workforce talent pipeline, which is, I think, getting it ready to, well, it is. It's a key strategic element I think we're all looking forward to get that accomplished. So I'm going to give 2 examples on the acceleration of the technology piece. One's I say too long, and one was too soon. So on the too soon one, we had a program. It was in the late 90s. It was a very pressing technology using ATR, using a LiDAR system in a cruise missile to autonomously select targets and also modify the response on the bird to that target. And it was a widely known program. It's LOCAS if you want to Google that. It made it on the Learning Channel or Extreme Machines or something like that. And we brought it to the warfighter. We were all proud. We had done a physical live drop, and showed that at least in the initial prototype it worked. And they saw the title. It had autonomous, and we were promptly shown the door. Now, that's not the exact storyline, but close to it. They weren't ready for it yet. And this is where, you're reading the minds of a customer. We've got an S&T mission for the Air Force, and we brought it to the warfighter. They had no requirement for it. And not only that, there was a lot of controversy stirred for the next 20 years after that program on this word autonomy. And now I don't think you can see a program on the books that does not have that adjective in there. And the second one is energetic materials itself. So, there's been explosive molecules discovered. Everybody knows the TNT and HMX, RDX, and they sat relatively stagnant for many years. There was a specialty item come out of China Lake about 30 years ago, and a CL20. You may have heard that. And for a long time, if you sat on the S-curve of development, in that it was seen as no further discovery needed. And I will say the application of technologies and AI in industrial processes and reinvestigating some old approaches, as well as some of the policy from what we can and can't look at from the sensitivity of energetics. We've made some huge gains, and so we're transforming really a hundreds of year old type policy, or not policy, technology boundary, utilizing some new tools, and some of that language even got put into the appropriation NDA 24 in this whole thing, and looking at some new energetic molecules. So that kind of bounds where we were too early on one, and now we are coming after studying some old problems, being able to make some tremendous headway in that. So how do we do that better? Modeling and simulation is a big deal. We are able now to, with the computing power and some of the data and some of the really quantitative analysis show that that solution, which is a subcomponent in the system, is going to give value to that customer. And that's getting at some of that lean kind of construct where you have value proposition up front. And the other part is just having us think about it, that strategic vision further. So a lot of us are in the mill, time for strategic planning. You're looking at a 1-year or 5-year kind of map. If we could take and put sort of that 10-year vision out there where it's a disruptive kind of mindset, almost where you're starting to think a little bit on the ridiculous end. What it allows you to do is approach the problem from an evolutionary planning piece to some of that truly transformational kind of thought. And I use an example. So in the nursing industry, it's kind of a benign, I don't know, benign, but it's not an engineering answer, but it's one I'd heard on a recent podcast, where if you're looking to replace gastroenterologists from the nursing end, you might just, on a 1-year plan, hire that nurse, train them, and then they go and perform that function. If you're looking a little bit further out, on, let's say, a 3-year horizon, you may look at other functions, other nurse functions, or even doctor. They may be able to perform the function from the gastroenterologist kind of approach. But if you put on that 10-year window, you're looking at maybe ingestible diagnostics, where you don't have to have that specific talent. You're using a technology solution to get at it. And so when we're talking about the accelerating and technical maturation for implementation, I would say we got to probably can some of the early near-term stuff and really take that far-term look at things. On the data and digital world, I think everybody's going that way. Air Force, you heard earlier, Lauren set the wonderful stage for this piece of it. But I saw that Kyle Hurst has an entire briefing now tomorrow on this agenda on the Air Force's digital transformation, digital effort. So I don't want to take thunder in that realm, but I would say that from a weapons end on the digital transformation, one of the things we've got to do is we've got a workforce. We're bringing in new technologies. We've got things like open systems architecture. We've got software-enabled functionality now. And we have government reference architecture, model-based. We got a lot of acronyms. And one of the things that I think we need to do if we're going to truly accelerate and get the whole of nation involved is some of the small businesses. So how do they get to be a piece of it? How do they talk the language? How do they even have the tools, the interface, and even the framework? So if you're putting out contracts with certain specifications, they don't have to learn that part. They're already up to speed, or at least on the same page. The last piece was really in the workforce talent. I know if I'm going a little bit long, I apologize. We've got, everybody in this room, I think, has this problem. We've got a little bit lower birth rates. We've got the baby boomer retirement wave coming up. So how do we take some of these tools and the AI, the natural language piece of that, and build some of the tools, mentoring or teaching tools that will sit available for the new workforce coming in, including, baby boomers may come. We're living longer. Technologies allow us to do some of the things that we haven't been able to in the past. And so, is it a retirement or is it a rewirement? And then what does the system look like with the retirees, or at least those people wanting to take a lot more time off, but being available as part of the corporate resource to mentor, train, coach, and put the context and everything that happens and bringing those new people into the workforce. So, hopefully those 3 areas, the accelerating that maturation, the digital data piece, and the workforce, I think those are really pillars of putting that on, bringing in new technologies and getting it applied.
Thank you. So one thing you talked about there that intrigued me was applying new digital tools to old ideas. So in that case was, to re-examine, something that was kind of been stable for decades. How do you actually do that? I mean, I'm sitting here imagining like a cold case unit, that basically sort of like a bunch of people in a room that say, okay, now we dust this one off and we take a look with the new tools and see. But how do you identify something that a new tool applied to can unlock a capability?
Yeah, good question. We've got a couple examples. There was a senior scientist we had that was taking the art, you know, as Julia Child's analogy, right? Taking the art of cooking and making it a science. Energetic formulations were a lot that way. And so now part of it is getting in a room and capturing that, interviewing the knowledge experts, reviewing, the following OIs in that versus, okay, some of the nuances that aren't in there as far as humidity or altitude. I mean, those are real factors when you're talking about some of the processing to get repeatable and all that. So capturing that, but then, formalizing that and applying some stronger modeling and simulation piece for a validation of those few data points. That's one area or one anecdotal piece.
Interesting. So this is all about expanding boundaries, and our next speaker actually noted when he sat down at the table in the green room that he seemed to be the outlier in this group. And it is actually interesting. We have 4 speakers here who you'd almost imagine would never normally sort of be in the same room together, but yet they're all talking about addressing the same problem. And our next panelist is Chris Moran. And if I get back to the beginning of my book here, Chris is the Executive Director and General Manager at Lockheed Martin Ventures, which is the venture capital investment arm of Lockheed Martin. He says he wears 2 hats. He's going to speak with 2 hats today. I don't know whether he'll actually take them on and off or whatever, but one is the kind of the Lockheed, internal Lockheed thinking, and the other is the external looking Lockheed
My day job,
piece of it.
yeah.
And he was previously with Applied Materials, which is a big company in the semiconductor industry. In fact, they're a very active venture capital investor, which is quite surprising to me. I found their name popping up in a lot of startups that I track now, and it turns out that Chris started that program at Applied Materials. So, Chris, take it away.
Yeah, well, thank you. Like I said, I'm the odd man out here. I don't run a major government research lab, and I don't have a team of engineers working for me. We're the investing arm for Lockheed, as you know. And if you don't know Lockheed, there's a slide up here that I put together quickly this morning so that you see some of the cool things that we've done recently. Particularly on the right, we're associated with the OSIRIS-REx program, with the lab at JPL, obviously, GPS, which, Graham, you were just talking about this morning. We're reconstituting that constellation. And little known to anyone that we did the camera on the James Webb Telescope, which gives all those wonderful pictures. So Lockheed has been involved in space for 70 years, I think, since the space program started. What some people don't know is that Lockheed started as a startup in San Francisco in a garage in the early 1900s. The Lockheed brothers were making seaplanes right at the time where there was the boom in aviation, right after the Wright brothers proved that it worked. All these companies, Curtiss and McDonnell and Douglas, and everyone got started around the same time, and Lockheed was part of that. So it's actually a San Francisco-based company, which you would hardly ever know from that point. So we're fairly large, $66 billion this year, 116,000 employees, and no, I don't know all of them. So when you come up and ask me if I know somebody, I probably don't know them. Anyway, go to the next slide. And so I run the venture fund at Lockheed. Been very, very supportive from Lockheed that we probably run the largest venture fund in the aerospace industry. It's a $400 million fund. To date, we've invested in 75 different companies. About a third of them are space-based. Another 10% are purely aeronautics, and then the rest are all those areas and domains you see underneath. So a little bit smattering across the board. So I operate sort of at the interface between technology and finance, where I have to decide not only will the tech work, which surprisingly enough, and of course I rely on the 100,000 employees of Lockheed to help me do that, but we have to decide first, does the tech work? Second, is it of importance to Lockheed Martin and our customers? And then thirdly, will it make money? Because we want these businesses eventually to be able to stand alone and profit, and that sometimes turns out to be the hardest part, to figure that out. But it's never done literally in a vacuum. Things change all the time. For one instance where you're talking about how we're transition tech into the company rapidly, I think as we saw the beginning part of this decade, we saw launch costs drop precipitously, right? From $100,000 a kilo to below $10,000 a kilo now. Now that's really important in a number of ways because it enabled cheap payloads to go to space, right? You would not launch a $10,000 payload on a $100 million launch mission, right? It just makes no sense. But now we're at the point where the cost of launching is, in many cases, cheaper than the cost of the payload. And so you look at a whole number of companies got created around this time. There's probably over 2,000 space companies, for instance, just creating payloads and mission planning and software and so on in the space industry alone. And as those costs dropped that fast, I think companies like Lockheed couldn't keep up. The government was very interested in small, resilient payloads going to space. We're obviously, we build GPS, which is like a 2,000 kilogram size payload, the size of a school bus. And in able to sort of catch that falling knife, we had to work with outside partners to do that. So one of our investments was in a small satellite company that Lockheed embraced rather quickly. I think over the period of about 6 to 8 months, we started integrating payloads with them and then started doing early launches with them. We called it Pony Express because that was the kind of the incentive inside the company to do that. So we put payloads up in space, very uncharacteristically, testing out technologies before a government contract. But as a result of that, earned some very big government contracts through the SDA program with this small company. I think one was about $900 million, the other one was about the same size. So here's an example of where we're able to integrate small tech very rapidly into the large company and bring it to the customer in a way that was both cost-effective, timely, and valuable to them in the process. So we continue to do that, and that's where I'm trying to operate in that space to do that.
So I'm looking at the list along the bottom there.
Yeah.
Has that changed much since you set up LM Ventures? Have you added or removed things from that list?
The total list has that list down at the bottom has changed a little bit. I think a focus on PNT recently. I think when I got to Lockheed, we make GPS. We don't need any PNT. Now we need PNT, right? So we want alternatives. We see what's going on in Ukraine. We realize that there are gaps in the system. So we're trying to work with small companies to figure out.
And how is that list drawn up? Is that the chief technology officers of the units getting together and saying what they want? Is it the who?
No, it's actually a great question and an important question for anyone trying to set up a corporate venture fund to answer this the right way. The way most venture funds are set up, they have a group of people called LPs or limited partners that give them money. And it could be 10, 20, 50. In a corporate venture fund, I have one LP. That's Lockheed Martin. And you want to serve the needs of that partner to do it. So we spend a lot of time. I would say half of my group's time is spent talking to the business groups and trying to figure out what they are interested in, what problems they have, what gaps they have in their technologies. And then we add them to this list. And below this, there's another 2 or 3 levels of extraction, onto specific areas that we're looking for. So we sort of call this the shopping list. And so literally our antenna are up when something comes through the door and it hits one of those. We're like, okay, let's get on it. Let's go talk to them and find out about it. And that's the way venture works. Yes, we go out and try to find things. We'll go to conferences like this and meet companies and entrepreneurs. But a lot of times stuff just shows up. And sometimes it fits a beautiful niche on that. Sometimes it's so cool that no one ever imagined it, and we bring that in too. So it goes 2 ways. So sometimes the business groups say, hey, I need this, and we go hunting for it. And other times something cool shows up, and we just bring it to them and say, whoa, we never thought of that. That's really cool. And that happened a few months ago. We found a company in Chatsworth that can manipulate sheet metal in a way that no one's ever seen before. And it turns out
in effect, the English wheel.
Basically,
it's the mechanizing, the handcraft of the English wheel.
You know the company is. Basically, they spent a year talking to sheet metal workers in the San Fernando Valley who hammered out fenders for cars and learned their processes, turned them into AI manipulation, and now can do the same thing at large scale, up to 20-foot length sheets of metal. And that's really cool for us because that speeds the time that we can prototype an aircraft, right? We can use these for the carbon fiber molds. We can do a whole bunch of things with it. We can replace sheet metal on a 50-year-old aircraft where the molds are gone. And so no one imagined that this was possible, and all of a sudden we're in every single business group is operating with this company right now to make that work and bring it to fruition. So the other thing that changed on this is that Lockheed's been great to double the fund when I joined. So we were a $100 million fund when I joined. 2 years later, we were 200, and then 2 years after that, they doubled it to 400. So they're very committed to this activity. You know, I'm proud to say they're very open-minded in terms of where tech comes from, and that's been great. Lockheed's been a great partner to work with, and I think if you ever talk to any of the companies invested in, they'll tell you the same thing. We've been a great partner for them and trying to get them into the defense industry, but also working with Lockheed as a partner as well.
So as an aerospace apprentice, I learned how to do that English wheel bending of metal thing on the Hawker Siddeley Harrier. And if anybody's ever seen a Hawker Siddeley Harrier, there's a lot of curves on a Hawker Siddeley Harrier, all done by hand. So our final panelist, and again, we're jumping over a boundary here, I think, but our final panelist is Dr. Charles Norton. He's the Deputy Chief Technology at NASA Jet Propulsion Laboratory. He joined JPL in 1998 and has been a principal technologist in the Earth Science Technology Office, as well as managing many small satellite missions for NASA. So, Charles.
No, thanks very much.
Welcome.
I'm really pleased to be here. So, as you may know, JPL is NASA's lead center for remote exploration of the solar system, all done robotically. We do, of course, partner with other NASA centers, other government organizations, industry, and academia. And, you know, really fundamentally in terms of this panel, we're a science-driven organization because we are doing scientific exploration, but much of that is driven by technology advancements. So we have a very nice synergy and interaction between the science drivers that come from the community, from the national academies and decadal surveys, as well as the technologists that are looking at, you know, what are the key new capabilities that are going to enable what in most cases are first-of-a-kind missions to expand our understanding of the universe at large. So there are many areas where we perform technology research and advancement to support this. Of course, AI, machine learning, data science, autonomy has been talked about quite a bit. But even areas such as advanced manufacturing and smart materials, data systems advancements, quantum sensing is becoming a very, very important area and focus for us to look at new measurement techniques that could provide capabilities that traditional sensors won't provide. For many years, we've made critical advancements in instrument technologies, ranging from spectrometers to radiometers, improving their sensitivity, their performance, and even areas such as in deep space communication. I'm sure many of you are familiar with the Deep Space Optical Comm experiment on Psyche, which has been really performing fabulously for us, and I think will be an enabling capability for many future missions. You know, I could go on and on. But really, I think the main message I want to convey is the nature of the scientific questions that we want to ask, the way in which we pursue them, our ability to derive knowledge from the observations are really being driven by technology advancements and transformative technologies that will be critical, not just for the future of our agency, but quite frankly, for all space agencies that are performing remote sensing.
So again, a bit of a chicken and egg question here. Are you kind of sitting there with a wish list from the scientists saying, this is what we need to know, and then you're kind of looking at the technologies that match that wish list? Or is there sometimes technologies that you think, okay, if we take this technology to its conclusion, it can unlock this? I'm trying to work out, is there some sort of balance between, because scientists are a very vocal bunch of people. I mean, they make it quite clear what they want to know. So I just try to work out, you know, really what's the driver? Is it that pushing the technology so you can unlock things, or is it saying, I've got a priority list that I've got a service here and I've got to find technologies?
You know, it actually is a really deep question because as you've conveyed, you know, the scientists and the science community do know what it is that they want to explore. But, you know, I would say traditionally, for many traditional scientists, I hope I don't get into trouble here, you know, they haven't necessarily been driven by the technological capabilities that can most efficiently or most rapidly enable the answers to those questions. You know, for reasons that I think can make good sense. Oftentimes, the very traditional approaches, the safe way to make the measurement with the least amount of risk, which will, you know, pass the review process well, has been a driver in the thinking. But I would argue not that all of the low-hanging fruit science questions have been answered. There are many deep questions, but we're now in a regime where the nature of the observations and the questions that are of great interest are dependent on, you know, very advanced technology capabilities that either have to be invented or modified from prior approaches in order to get at the most exciting questions. And from the perspective of that community, that's what keeps them motivated, that's what keeps the advancement in the theory and the practice of the questions of interest moving forward. So there is a synergistic relationship where even at JPL, we're focused a lot more now on tightening the interactions between the science questions that are being proposed and the nature of the technology capabilities that have to be invented or developed to address them. And I would argue, although sometimes people will argue against me, we're even moving now into a regime where there are technology capabilities that can even start to drive the nature of the science questions that are being asked. So you don't necessarily have to think about, you know, how is it I'm going to make a particular measurement with the tools that I have. You can even start to expand your thinking a little bit and consider, with the particular technology capability that I know either exists now or is emergent, what are the types of questions I couldn't answer before? And what are the regions of exploration that I could start to address that would be new? And if I'm willing to understand the risks involved in adapting and utilizing that capability, it could be transformative for the types of missions that we want to develop and perform in the future. So there is a lot of back and forth amongst these communities. That's, I think, is very productive.
Fascinating. So, are we ready with the Q&A? I have questions, but I will arm myself with the laptop. So my first question is mine, and it just intrigues me because of the makeup of our panel. We have, So we have shareholders who want returns on investment in 3 years. We're always told that anyway. We have the DoD with a 5-year budget planning cycle. We have the scientific community with the decadal surveys, and I'm afraid I don't know what happens with you guys, but I'm sure you have a similar planning cycle. How do you go about building a constituency for a technology or a capability that can then get that technology from a light bulb idea to an actual system? You've got to bring in. You've got to convince the customer. You've got to. I mean, are there any key steps that you need to do when you go out to the edges of your visibility? See something you think's got value. How do you start to build a constituency to make sure that survives and moves down up the maturity curve to become a system? So, Dave. Sorry, I'm bad with names. I apologize.
Good. Go by David. Yeah.
David. Sorry about that.
Yeah, it's a good question. S&T end of the DoD is much different than the big program level. So you got to appreciate where we're at in that technology line. So I'm in the S&T end, and we know we're hoping for a whole lot of aggressive, higher risk kind of push. So if from a program, you know, there's the POM, the planning cycle, and that, and there's warfighter requirements. There's scheduled programs in line. So typically, there's three ways to get our S&T in there. One is they have a problem with the current program of record, and there could be new approaches. We had a program to demonstrate in a program of record a collaborative system, and that was, I wouldn't say it's a whole new system, it was a whole new capability, but getting advocacy was easy when it was, let's say it was asked for at a high level. We responded and demonstrated, but then they came back and they said, well, we put it in a system that didn't have the legs, didn't have the reach that we needed, and so they let us go back and reposture to more of a science and technology development and collaborative autonomy kind of systems. The other part it would be is if it was a current program and there was just a flat-out failure, right? And so we have technologies in-house to do what we call 911 calls, right? And so this is, putting in technical solutions that have been in the books. We had some idea, or quickly developing a solution. I would say, for a distro A audience, there's been some material failures because of their applications, and we had some ideas of alternate material solutions that would get put in there. So we had that. And the hardest way, which I think you're asking, is how do you get new concepts in there? And how do you get them to get traction? And so it's a dance, right? We have customer interaction. We have multiple customers. We have anywhere from mobility command with large airplanes to global strike, which is a little bit more on the serious end, and then combat command. And so what we do though is there's forums, collectives. So I'm one directorate of many within Air Force Research Lab. But it's a technology presentation, listening to some of their gaps, and then sitting close to those acquisition offices to make sure that they're aware of our technology. And it does take a little bit of a time, right? You're going to propose, they're going to say, no, we don't need that yet. And then there gets to be a time, like GPS, came out of the lab. It was, we want to say no until we can't live without it. And so Air Force has formalized a lot of this a little bit better the last few years. And how do you get prototyping and demonstration of promising capabilities for a better unification with what the Air Force customers are asking for. And that whole pipeline process, obviously you're going to minimize a lot more high-risk attempts, but you're going to hopefully increase the probability that those few new capability shots you're going for make it and transition over to the warfighter.
So Chris, whenever I deal with startups or venture capital, they always talk about the importance of the CEO being a storyteller. Right? So when you're at this interface between technical and finance, you've got to listen to the story they're telling you, but you've also got to tell your own story, because you've got to go inside Lockheed now and try and sell that technology or whatever. I mean, so how do you build? I mean, what are the things that you use to build constituency?
Yeah, it's probably the age-old problem that every corporate venture fund has to deal with. So the first time I bring in a new tech to some SMEs in the company, the immediate response I get is, "Oh, we could do that." And I'm like, I know you could do it. You're Lockheed Martin. You can do it. Enough time, money, you can do it. Like any one of these gentlemen could do it. But you're not doing it. So what are we going to do about this, right? So we have to start with that spot. Is this valuable? Have these folks made enough progress? Is this something that you want to see? Do you see a trajectory where their maturation is going to meet a need or a potential need? So it is a story we have to create. But we can't create it unless my group understands the context, right? Where is this going to fit? Which group is going to be most interested in it? Which customer are we targeting with that? And so you have to build that up over time. And generally, our investments are actually quite small in the very early stage of the company. So there's not much there. I mean, it's a few people, working off by themselves for the most part. But after a year or so, then they need some help. They need some support. They need some, let's call it fine-tuning, shaping of their mission or where they're going or what the customer needs. And that's where a Lockheed partner comes in hand to help them do that. But I see as Lockheed gets more engaged by helping the company gets more engaged with Lockheed at the same time. So it's not like an epic type thing. It happens over a long period of time. We sort of bring them in there. And then, you know, sometimes the company doesn't work out, the tech doesn't come through, whatever, and they just drift away to, you know, probably pivot into something else. But sometimes it works really well, and we have that great engagement. Lockheed is starting finally to step in on electric flight, for instance, right? We've done several investments in that area, and for a number of years, it was pretty much, those are toys. We don't want anything to do with that. You know, we make jet airplanes and don't want to deal with that. But when you get down to the point, you point out to the helicopter group that, hey, somebody's going to make 5,000 helicopters, electric helicopters, and you don't think they're going to compete with you? I mean, at some point, finally lights go off and like, oh yeah, we better understand what's going on here. So that's where we play in that space. And I like to think that we fit in the innovation pipeline in a way that other groups don't. That venture companies generally take 3 to 5 years to mature and develop a widget or something that's useful. And most large companies have a 3-year planning cycle. So we're just outside that planning cycle. And it's amazing how, you know, since that planning cycle is used to make budgeting decisions in most of the major programs, it's amazing how blind a company can be at 3.5 years or 4 years or whatever. So we fit in this nice spot just outside the planning cycle. Our stuff, after a couple years, starts to migrate into that cycle. In fact, my group has been invited now to participate in all the strategy planning sessions of the company because we're seeing things a little bit ahead of need. And so we're trying to impact those cycles and that thought process with that as well. So we're trying to figure out where this fits. We call it a new business tool of the company. You know, most large companies have a M&A group, you know, for buying companies, and other companies have, you know, obviously research arms, but that part in the middle, which tries to cultivate outside research and bring it in-house, that is missing in a lot of companies. We're trying to build that inside Lockheed.
So I'll take one of the questions from here. We've already touched on it a bit, but I'll come back to that one. It's just moved down one. So the industry as a whole is facing a kind of a talent issue. We got a lot of very experienced people who are reaching retirement age, et cetera, you know. And we have new engineers, new graduates with a very different view on life. So the question is, how can we augment an increasingly older workforce with advanced computational and AI-driven frameworks? How much can we rely on these technologies to replace that decades of experience? And, you know, or how do we, if we can't totally rely on it, how do we use it to the best advantage? Do you want to talk about that?
Yeah, it's an excellent question. I mean, what we try is to have a transition period with an overlap of the retiring workforce with incoming younger one to do it really from a human to a human, and not have some tools. Of course, you have the documentation and everything, but I mean, reading documentations is something different. So it's a difficult task because it really needs a very long-term planning on resources, personal resources. I mean, when you have somebody retiring in 3 years, you often don't have the money to pay somebody else with this overlap. But I think this there may be tools, AI tools, which can do that in a good way. And of course, you have to preserve all this knowledge, but still, you have to really try and then to invest in this transition period, I think.
Do you think it could be a driver for the investment? I mean, if you're looking at a skill base, you know, that is declining, and you look at the advances of AI, can you see an opportunity to say now is the time to move into more computation, you know, to apply these more computational tools, because we're in that sort of downward.
Yeah, sure, because also the knowledge of the new ones is different, and the expertise and what they need to know. So I think yes. The answer is basically you have to use these tools. They have to be developed. I mean, that's not something we are doing, but we would be would support people who would develop such tools.
Charles, your JPL, a lot of your missions are incredibly long,
Yes.
almost multi-generational in the thing. So how do you see this? It's also a field that has just energizes young people to become involved in space. So you've got this kind of weird, sort of almost like two things going on. You've got these, missions that you need to retain the expertise for decades at the same time as you've got people who desperately want into this field. How do you see these? I mean, do you see AI, computing, et cetera, as a way to enable that, manage that?
Oh, well, yes, absolutely, but perhaps in a different sense than some people might initially think. So within JPL, roughly 1/3 of our current employees have been there less than 5 years. So we do have a nice young group of skilled individuals that are learning in an interchange fashion with those that have been around for some years. And we really, not only just within our lab, but within NASA in general, have moved much more directly towards a balanced portfolio approach for mission development. So it is true, there are missions and capabilities that will take years to develop, and we understand that. But we also have a mixture of much more rapid, fast, more risk-aggressive missions that we're performing that allow for a variety of opportunities for really individuals across our whole skill base to get engaged with space exploration. So I think our approach in general, which I think is very effective, has been one to allow for a mixture of opportunities to exist, which span not just career advancement opportunities, but also opportunities in terms of the intellectual challenges one would experience when trying to develop and deliver a flight mission to show a science capability within 2 to 3 years versus one that may take 15 years.
So are those shorter, higher risk missions, that's a deliberate decision in order to create those opportunities, to learn something, but also to create opportunities for the workforce? So.
Yes, absolutely. And it actually is very beneficial because with those missions, which tend to involve smaller teams, individuals get to see the whole process from formulation all the way through development and operations and termination and data analysis. And that viewpoint and experience is one that individuals bring forward when they may play a specialized role in a large mission. And that allows them then to ask deeper questions in the context of the work they're doing with respect to others that they're partnering with. And that helps reduce risk. It also brings a greater efficiency and I think a lot more interest to the individuals that are actually engaged because they no longer see themselves as a small part of a large wheel cog where they can't really see the whole picture. They understand the role that they have from that perspective.
So Chris, if we were to look at your 75 startups you've invested in, any or what number of those would be because you want to tackle a problem inside Lockheed, like you want to bring technology into Lockheed to tackle that whole issue of tools, computation, workforce, skill transfer, and a subsidiary question, is it also an opportunity to give your own people experience, to get them out to the startups for a period of time, have a different environment, and then come back bring that back into Lockheed?
Yeah, good. I'll put my Lockheed hat on now. So that's for Lockheed. So one thing Lockheed is engaged in is this major overhaul of all our information systems. I think I might get the number wrong, but it's like $150 billion over 10 years. I mean, it's a massive, pull it out, replace it, and it's going to touch every aspect of how the company runs, from design, from ideation to actually delivery onto the factory floor. Every part is going to go digitally transformed from end to end. And all those things represent an opportunity for capturing knowledge through AI and methods like that. So we've been pretty much asked to look for any repetitive tasks and try to, how do we automate those? How do we start eliminating? So freeing up people to be more creative, to work on more difficult tasks and get the mundane daily, moving data from column A to column B to apply a model on it, do that. But also in the engineering ranks, trying to automate some of the repetitive tasks that go on there. When you've got 3 simulations all feeding each other, when you've got CFD feeding something else, feeding finite element, feeding that, and you make a tweak in one and it has to tweak all 10, can we automate that instead of bringing 50 engineers to do that, run those models in real time, and all of a sudden you've got a 3-week process that you could probably reduce down to 3 days using some level of automation where these things are all linked together and do that. So we're looking at all that stuff, and we're trying to find companies to work across that space to help Lockheed populate that as well. Of course, Lockheed's doing a lot of that work themselves. So there's a lot of value there, even in mundane aerospace tasks, right, or things that you would think were mundane to change that. But we do run into one problem. Since Lockheed works on so much classified stuff, this is where large language models collapse for us, right? Yeah. We can't put all that classified information into a large language model to populate it and provide that knowledge, the decades of knowledge that may have been accumulated on classified programs, because you can't mix that data. And so maybe you guys have solved that. We haven't solved it yet, but that's a really tricky thing. So we're trying to find companies that work in that space to try to figure that out. We're actually talking about small language models as opposed to large language models, where we're very, very focused on a specific domain or task, and trying to work with companies to develop that as well. But that's one of the challenges we have with that. You can see the tool right there, but you can't use it because of the restrictions on how information.
Yeah, this actually feeds into what currently the one about. Well, just keep moving around, but. So the question is, how can we use the rapid advances in AI to help the warfighter without compromising national defense from leakage of information? And David, I want to go to you here. I mean, you talked about working with small companies, but you also, we've all talked about computation and AI. How do we bring it in, particularly when it's being developed in the commercial world? How do we bring that in and use it, but with security? I mean,
yeah, I think there's some efforts underway to try to get at within some of the DoD groups, but nothing large scale. And it's going to be a problem, right? We are trying to keep things a little more tight than more open, and that's a lesson. So I will say, it brings me back. This time of year, we're entertaining in-house for our bench level S&Es for innovation funds and that, and I'm really pushing them. Don't give me the increment that wasn't funded 2 years ago, and you just need a little bit more money, right? I want you to strive like generation after next, not next gen, generation after next. We may have pushed them a little bit, but one of the things that I saw in those, and I told our director, was the pervasiveness of what I'm seeing in machine learning, neural networks, and the AI end of that. It's coming into those. So the workforce, we talk about the skills, talent, and all that. Some of the best proposals were some of our most senior folks. And so the promising thing, and you're getting back to your question, is I think it's just going to come in there through, we're in a transformation, people are learning, there's tools, there's rapid elements of it. We can bring it in and some of the open research ends, and we can apply techniques or develop some techniques on the S&T end. And the big question is, how do we get them into the big systems in that, right? And I think they'll work. Validation is huge. We haven't had that problem solved. Certification is huge. One of the big limiting factors for my directorate is, you have a new concept, great. It checks a lot of boxes, great. You're not hanging it off my multi-million-dollar platform. Because that whole certification process is very rigid. Maybe we're not bringing AI in actual concepts as fast, but how do we use some of those tools where we can get at on integrating new, say, systems capability? Because some of these items that, even though Lockheed we designed it, Lockheed can make it, we can't really share, across certain security boundaries and all that. But the end game, how does that system get integrated into the platforms for a real capability, so we probably can carry it somewhere? That I think we are making progress in, and that is an area that I think that we continue to learn, we continue to rise, and it's helping us go a little bit faster. And I don't know if that answered it.
Chris, do you think there's are you seeing any companies that are kind of working in this, I don't know what you'd call it, how you secure machine learning and models and natural, is it something that's beginning to be looked at that may?
Yeah, they're kind of beating around the edges a little bit. They first started off with like secure domain operation, put all your data on our secure cloud. But to that specific question you're after, can they secure that? You can't have information flowing from one program to the next, right? That's the problem, right? You can see the value of merging that info, but you can't do it because of the restrictions on it.
You can do it with human beings, or you can largely do it with human beings because you control access or whatever, or the human is the policeman type thing.
That reduces
You've got to
the
get
value.
that thinking into a machine.
Yeah, but it totally reduces the value of what you're trying to do. So like I said, you can see the solution, you just, the regulations prevent you from actually solving
You can do it once.
Yeah, that's right.
So when we were in the preparation for this panel, one of the things that we ended up talking about was cultural differences when it comes to this, right? So we have one European on the panel, and I suppose I am as well, but and 3 Americans. And you're told that European graduates are a more scientific education, and they have a different view on things. US may be less scientific, but this is a country of tremendous innovation and tremendous creativity. So I just wanted to explore about how you see that playing out. Do you see those cultural differences? Do they affect how the technologies get applied? Or is it something we can leverage to get a better result by bringing the different cultural approaches together?
Maybe I start with a European perspective, and then even with a...
I have to say I'm not European.
No, sure. And then even Germany itself is then also another ecosystem, of course. I think the difference is not so large when I look. I'm also teaching at the university. Right. I'm teaching in the Master Aerospace Engineering at Stuttgart University, lasers and optoelectronics for aerospace applications. So when I see the young people, they really, they have their ideas which they want to bring forward. Also, a lot of them also are thinking about being entrepreneurs and having startups. And the ecosystem in Europe is much smaller. But I think what you said, the education may be more traditional in Europe, at least in German. When you study aerospace engineering, I would say it's the same like studies 20 years ago. So you do all the hard stuff and you solve the Navier-Stokes equation and things like this, which is what I said in my opening statement. You need a strong foundation, and that's what you get. But also that helps you later. Once you know how to do to solve difficult problems, and not only how to prompt the solution to a problem from an AI. And I think that's what they learn in their studies. But at the end, I think the young people, they are also interconnected to all the other countries and other students. They have the same very good spirit to bring forth what they are interested in.
So Charles, how culturally diverse are you within JPL? And if you are, do you see benefits from bringing those different viewpoints to the types of things you do?
Yeah, no, really extremely diverse, both in personnel and in our interactions. Of course, we collaborate very closely with DLR on the GRACE mission, and we're in formulation now in partnerships for future gravity measurements using quantum sensors. We're working very closely with ISRO, the Indian Space Research Organization, on the NISAR mission. So a shameless plug. Be sure to visit the exhibition and take a look at the NISAR model at the JPL booth we'll have later here at SciTech. We just had a wonderful collaboration culminating in the Surface Water Ocean Topography mission with CNES in France. So we have a very healthy exchange, both in terms of the technology capabilities that we develop and the missions we develop and the operations interactions. But it's funny, when thinking about this question just now, I was just thinking about my kids and most university students. It seems like there are more opportunities for university students to study abroad and to interact than was the case when I was in college quite some time ago. So I think by nature of the work that we're performing, and I think by the nature of the future challenges that we're going to face for scientific exploration, it's going to remain interdisciplinary. It's going to rely on these types of interactions. Of course, there are competitors internationally as well in areas of interest that we're all aware of and are trying to understand how to pursue. But even, that being said, the diversity of these teams is going to continue to be the strength of our ability to innovate and advance.
So your customers, the scientists, presumably that's an international community because most of these space science things, it's not one country wants to know what's on the other side of the moon. They all want to know sorry, it's a dumb thing, but I mean, it tends to be an international scientific community that is asking you for something in the first place. So.
Yes, absolutely.
So Chris, you presumably do invest globally, and do you see a difference? Is it something that you take advantage of because you see different approaches in different places?
No, absolutely. Cultures across the world have a different risk tolerance, right? So I'm in the risk game, right? That's what we're trying to do, try to find big growth opportunities where the risk is manageable. And we see that different countries, societies, whatever, look at risk very, very differently, right? The way we approach every investment is, we'd like to get a return on it, but we accept that we may get nothing. Not everyone has that same view of the world, right? That they want to get something, and if you have to get something, then the way you look at the challenge is quite a bit different. Also, depending how unformed the idea is, will bring people in or not. I spent a good part of last year helping NATO get their venture fund set up, this €1 billion fund that is now just starting to invest. And the challenges that we had negotiating with 27 countries on what they wanted to get out of it and how it would work, and we'll see if it works going forward with that. But just trying to navigate that is quite difficult. And the other interesting thing about risk that I see is that large companies, and I won't name the company that I work for, either have zero risk tolerance or take it all. And like, whoa, I mean, there's so much more between those two things. And it's almost like, we're so late, we haven't thought about this looks like it's gonna happen, let's just do it. And like, whoa, you didn't even think about, so do you wanna lose $100 million in a year, or do you want to lose $1 million in 6 months, right? And that's kind of the way you have to start looking at what's the cost of the risk and how much you want to tolerate. And if you look at risk or failure as a learning event, what are you willing to pay to learn? And you start thinking it that way, then you start understanding how risk really is and what you're going to get for it, and you can make decisions a little bit quicker going forward with it. But if you look at it as an event, then you're going to make the wrong decision.
Thomas made the point about the ecosystem in Europe, the startup ecosystem in Europe. Not as well developed as the US, not as big, not as well funded. Do you see that as a problem either for a company like Lockheed Martin or for a region to say that it would benefit, a stronger ecosystem would be a better result? Or
yeah, things have changed. I think the last 10 years, money was free, basically zero interest rates globally, and tens of thousands of companies were created. Maybe half of those should never have gotten money to do it, right? And they're all going to have trouble over the next couple of years. We're starting to see that. A lot of the space companies who wanted to, build massive constellations where it was 5 years before they'd see the first revenue dollar, are starting to struggle raising that next dollar right now because people don't want to take that risk. I have to pay $1 billion to learn out that it didn't work? No, that's not where I want to be on that. So to your point, though, having a support system of entrepreneurs, of people familiar with risk capital, of people that want to provide risk capital, right? The emergence of family offices was something that wasn't really around a decade ago, but now there's lots of wealthy individuals that want to help these things get started. There's corporations like Lockheed and others in the mix now. And even some of the larger firms, the BlackRocks, the Cerberuses of the world are leaning in on earlier stage companies. They're not all doing private equity things. So there's a lot more money coming in. But the challenge is these higher interest rates right now, because that changes the whole calculus on the time, return of money. You know, a year or a couple years ago, $1 in your savings account was worth $1 a year later. Now it's worth $1.05, and when you're talking big numbers, it's a lot of money. And if I can make 5 to 7% in a savings account, and when the average venture return, you know, is 7 to 8% with a lot of risk, I can get 7% with no risk, you know. So money is sort of flopping around to other areas right now. So I think that's a challenge right now to figure out how to bring it back for those opportunities that represent a big opportunity, a big growth opportunity with a measurable amount of risk.
So do you get much opportunity to work outside of the thermos bottle? Thermos flask is the US defense community.
Yeah, again, going back to that S&T end of it, so we're looking at basic research to some of the implied. And in that realm, I've got 36 years in Air Force Research Lab. I'm blown away at the opportunities that are presented right now. We've got, if you're willing to take that. So, getting out like that, it's anywhere from 6 months or less with a signature of your boss for a basic research Windows on the World opportunity. So we can team up and go to universities. We can put in for a couple of years as an engineering exchange sciences program. A little closer, though, if you had a venture mindset, and we've had handfuls of examples, there's an entrepreneurial opportunity program where you have an idea as a researcher, it's your IP, you can go out for 2 years and run a small business to try to get that to sync up, and there's a lot of help to try to get that engine started right from the small business end of that and the business sense of it. So international, we're not going to do anything in the future without our partners. So, and that goes all the way up to the top of DoD, but from a science and technology end of it, I would say the international activity is as large as I've ever seen. I've worked other societies, Hypervelocity Society, the aeroballistic smaller groups where I got insight, particularly in Germany in some areas that they're phenomenally efficient because they have to be. So, one of the DoD curses that it has and blessings is money, right? And so when you have to limit what you're doing and really focus down those priorities, you talked earlier on why does he have that big list and all that, those are all essential because they have to do with that value proposition. Well, similarly, on the DoD, we have different kind of dollars, but if we just looked at some of the partner nations, I think, and how they really got much more efficient and use this term lead, leverage, watch, right? Yeah. What are the critical core pieces that we have to own as a taxpayer, science and engineer, right? We're responsible, a very special mission there. I think we focus on that, leverage the international partner. There's some excellent technologies all over that we maximize how we leverage that, work on, focus on what we're good at, and team better. Project agreements, a lot of these international agreements, you probably see the list rising because I think we are being encouraged to do just what you're saying is get out, get diverse, bring in some of those outside partner pieces of it.
They are playing in venture, by the way. You guys had a weapons pitch day, no lie, about a year ago, weapons pitch day down at Eglin that I had to go to. I just had to go see who's showing up with that. And I think you awarded $28 million of grants in one day to 11 or 12 companies. And it was a great event. I mean, surprised to me. But
Yeah, so I think they, when the former executive, acquisition executive, Roper came in, he stirred a lot of that kind of business sense to go after it a little bit differently. It's still the same dollar, it's still some of the same technologies, but can we put it together to get industry attention and maybe more importantly, access some of those entities that we hadn't accessed before just because it's not plastered on a, US Gov site.
yep.
Yeah, I might add, if putting the NASA hat now, taking that we're using prizes and challenges also as a way of tapping into this community. We have an entrepreneurs challenge where it's a very similar model where people can come in and pitch their ideas, and at the end of the day, they can be given some funding to go ahead and pursue that development with a NASA partner. So it's a very effective alternative mechanism for
So
exploring.
Thomas,
these new
I know
capabilities.
there have been spin-offs of DLR. I mean, H2 Fly, which is hydrogen electric, that was a spun-off from DLR. So to what extent do you draw on small companies, but to a certain extent, are you also serving them? Are you a technology sort of incubator or source for some of these?
Yeah, we have special measures to do that. Or we also have a new one in our executive committee. We have somebody who's responsible, it's Carsten Lemmer, for technology transfer and innovation. So we have different measures like, we have spin-offs and they are supported and they can for free license the patents which are made in DLR. The scientists can go on leave for a few years and they have the guarantee to come back if the company fails. And also we have a measure that only 50% of our workforce is on permanent contract. So the other 50% is a permanent change in order to foster that they go to industry and often they do a startup and that's now also supported with different programs. There are some additional ESA programs for that. So it's developing, especially in the past 2-3 years.
Right.
Developing.
So again, we talked about this earlier, but we're by and large talking here about the next generation, which can be a kind of a fairly long time frame. But technology doesn't always work on long time frames. Things can pop up, and the example that you can't not use is ChatGPT because it's potentially disrupting almost every function that involves searching large language databases. Basically, the things you can do with it. Specifically to David, you and Charles. You've fixed budget. You're federally funded. You have a budget. You plan that budget out for a long time. You've got a roadmap, and you're trying to move things down that roadmap. How do you deal with a technology that pops up? Do you build in the flexibility, or do you have a massively mad replanning session to say get that technology into there, and there? I mean, how do you cope with something that pops up?
Pop-up is a relative, right? Is it a stair function, or stair step, or is it a bow wave to it?
No, it depends.
So you adapt. We are internally funded quite a bit differently than say Navy in that we have quite a bit more flexibility. We do roadmap planning. We do talk with stakeholders. But those are sort of some of them are broad goals or where they're looking in 3 to 5 years, not necessarily that 1 year. So we can adapt, and we ingested technology. We reprogrammed dollars sometimes, according, not for those in the not against the law reprogramming. We have a broad description of what we have to work on with our money, but we were able to move it around to address some of these and bring it up and on ramp. I would say. I was there in the wave of hypersonics. I was honestly, from my end, on the weapons end, I was a disbeliever. I said it was way too expensive. There's other ways to get that. And I would have ventured, I would have been a bad investment on that. And so the AI end of that, I don't want to say necessarily autonomy, but at least the network collaborative system, we call it network collaborative autonomy, we adjusted, and there was a big infusion to demonstrate it in the system, and we adapted and we had to pull resources off certain programs, decennuate that a little bit, put them on there, demonstrated it within 18-24 months. So yeah, I'd say we have a little more flexibility than some to adapt, but we adapt.
Yeah. Charles?
Yeah, I would say, within the budget constraints and the nature through which missions are formulated and developed and the time it takes to field them and get them flown, we can't pivot as quickly as I would like. But again, it's a range of response based on that balanced portfolio approach that I mentioned earlier. For the small, cost-efficient, quick missions, those are ones where we can often take more risks to adapt and accept these new emerging technologies more quickly if we can show they will be of benefit, as opposed to ones that are in a long, fixed budget process, which is a multi-year process of getting the mission actually built and flown. But I would say, that being said, I think the impact of the rapid change in these areas, such as the generative AI, which you've mentioned, are impacting how we think about the future. Like, by the nature of the remote sensing work that we do in planetary science, and even to some extent in other areas of interest, AI and machine learning and autonomy are not new. I mean, we've used these capabilities, but now some of these more advanced aspects which feed into the generative approaches that are being used are influencing how we're thinking about the future, and there's definitely a role for these capabilities.
So forgive my ignorance here, but so if I came and said to you and said, I want to demonstrate, because I want to move the goalposts, I want to demonstrate a high-level autonomy in a deep space probe that can reprogram, so they can adapt to a change in the environment. Say, I can't do that anymore, I'll do this, or I'm in the right place to do that. If you could demonstrate that, you would move the technology needle a long way. Is that something that you at JPL can do, or would you go to the startups and say, that's your job, you go off and take the risk, then we'll look at a big, a mission plan, and we'll bring that technology in? Or could you be the one that says, we're going to put a mark in the map that says that's what an autonomous spacecraft can do?
Right. I think it's a mixture. I would say traditionally, if we were thinking about making a leap of that type, it would require some gap analysis and studies and some theoretical work to show that there's a benefit that can be gained. But I think now we're moving, as was talked about earlier regarding, the low cost and rapid availability of launch, moving more towards a model of just saying, well, let's put together a mission which could use these capabilities and demonstrate, at least at a rudimentary level, the remote sensing capability that we want to use in a future context. So if you can prove it and demonstrate it that it works, then that could rapidly move us towards more advanced and larger sophisticated missions which will adapt that capability. And there are many instances now where we've used that approach successfully.
Right. So Thomas, you wanted to jump in?
Yeah, I wanted to add how we do it when these new subjects pop up. So what we did in the last years, we funded really new institutes which address certain aspects. Like, we funded a new institute for security in AI. We funded a new institute in quantum technologies, and we funded a new institute, a national drone center. So of course we are also government funded, but the number of DLR institute increased from 34 to 55 now. This cannot go on like that forever, but we have measures to address these new topics. And then there are some loops that the new institutes, they have to work together with the old institutes in joint projects.
Oh,
so
right,
that the
right, yeah.
institute doing the combustion research has to work together with the institute working on quantum technologies or AI. And by that way, I mean, we have a good mix of expertise and people working together on this new topics.
So the question here is often when we talk about rapidly adapting, rapidly moving organizations, we talk about the skunk works. And it was the model, for aerospace for the longest time. But even the skunk works isn't the skunk works that it was. And the other works that were formed by and large have become much more institutionalized within the companies, and they become, in essence, the prototype, maybe the capture organization, but the kind of the prototype before it goes into the larger. A program is one and it goes into the larger. Does that mean that the likes of Lockheed has given up on the idea of Lockheed being an innovator?
No.
But when I'm saying innovator, I'm not just saying a better mousetrap or a sixth generation fighter. I'm talking about something that that these guys you're investing in are doing, something that you think could really move the needle if it works and if they get the money. Is that still going on inside of a Lockheed?
Yeah, no, it is. I hear this all the time. As the startup world has decided to lean into defense and aerospace, of course, the old David versus Goliath kind of stories come out, right? Oh, Lockheed's slow and don't know anything, and, and we're great and we're fast and we're cheap and we're doing everything right. And I've been in the startup world for 20 years, and I know that's not true either, right? So you can't play both sides of that. When you look at the things that these groups do and Lockheed does, you saw some of them. It's just amazing, right? No startup could do some of that stuff. It's just amazing, right? So yes, Lockheed is incredibly innovative, as are all these organizations to do that. But what we're not always is fast or cheap, right? And that's what you can get from some of these more aggressive companies that don't have the overhead, the infrastructure to support that. And I mean, the real solution is to work together, find a way to blend what we all do with sort of the energy of a startup company and bring the best to the table overall to do that. Because I think that's where the real value is. I don't know, not every startup company is SpaceX. And SpaceX, by the way, is not a startup company anymore. I mean, once you get past your 20th birthday, you're not a child anymore. You're bigger than that. So, I mean, it's a real company, right? So, but we still think of it like it's a startup company. So I think that's really the solution, is how do you blend these two domains to get the best out of it? Not that anything that any of us can do, or companies, not me, these guys are the pros here, to get what they can do with the energy, the drive, the cost effectiveness of a startup company. That's when the real magic's going to happen.
Okay, folks, I am probably going to stop on that rather than come up with a question just to fill the gap. So I'll give you all 1 minute, 43 seconds back of your day. So I want you all to thank our speakers, Thomas, David, Chris, Charles. Thank you very much.